Hello, I'm Yehan Liu. Welcome to my Lab2 report, which is about lines of charge. First, the introduction part, the purpose and principle using the lab. In Lab 1, we estimate the charge on a piece of tape by modeling it as a point charge and analyzing the balance between gravitational and electric forces. However, charge is actually distributed along the tape's length. So now we refine our model by treating the tape as a line of charge, distributing the charge evenly along its length. This allows for a more accurate estimate of the charge and provides a comparison between the point of charge and line charge models. And about the fundamental physics principles, we again use Coulomb's law to describe the electric force between charged objects and the principle of force balance to determine equilibrium. The gravitational force acting on the floating tape is balanced by the electric force exerted by the lower tape. Additionally, we consider the electric field created by a charged tape to model its interaction with the other tape. And about the equations involved, except for the first one that is the same as Lab 1, there's a new one that is the equation of the electric field of a line charge, which is used to model the electric field created by a tape with charge distributed along its length. Then about the model used in this lab, the experimental model in this lab is just the data we collected in Lab 1, where we observed the interaction between charged tapes to measure forces and estimate the charge required for one tape to float above another. No new experimental data was collected for this step. And then the computational model, instead of assuming each tape is a point charge as in Lab 1, we now model the charge as being evenly distributed along the length of the tape. This allows for a more accurate calculation of the electric force by summing the contributions from each charged segment. Here's a preview of the result. These two are the numbers we got from Lab 1, and we used them to get the result of Lab 2. So magnitude of electric force on tape B is this number, and the magnitude of gravitational force on tape B is this number. And this is the 3D image we got from the code. A quick review of Lab 1, and these are the systems and surroundings and initial conditions and the assumptions we made in Lab 1, and it's still the same here in Lab 2, but we just use the result we got from Lab 1. Next, I'm gonna explain each part in my code. In the first section, I define two key values based on Lab 1 data. The first is the mass of the tape, which is needed to calculate the gravitational force. The second is the estimated charge on the tape, which was determined experimentally. These values will be used in my computational model to analyze the floating tape's behavior. And then in this part, I define a function to calculate the electric field at any point due to a charged particle using Coulomb's law. This function takes in a charged particle and an observation location and returns the field strength at that point. Next, the line charge function creates a line of charge by dividing a charged tape into multiple small point charges. Each segment is assigned a fraction of the total charge and mass, allowing the model to simulate the charge distribution along the tape. Then this is an important part. I calculate the electric force on the top tape due to the charge distribution on the bottom tape. Each tape is modeled as a line of point charges, and I iterate through each charge element dq on both tapes. Then for each charge on the top tape, I sum up the contributions from all charges on the bottom tape using the electric field function. The total force is then updated, and visual arrows are created to represent the electric field and force vectors. Then the final part, I create arrows to visually represent the net electric force and gravitational force on the top tape. The arrows are placed at the middle of the tape with the electric force shown in white and the gravitational force in yellow. Finally, I print the magnitudes of both forces, allowing me to verify whether the electric force is strong enough to balance gravity and keep the tape floating. And here we got the result. The magnitude of electric force and magnitude of gravitational force is shown below. And so let's see some similarities and differences. Similarities are both models use the same experimental data, including tape mass and distance, and both estimate the charge needed for the tape to float. And the differences are Lab 1, which is on point charge, assumes all charge is concentrated at a single point, but Lab 2, line charge, instead, distributes charge along the tape, making the force calculation more accurate. Two possible errors are uneven charge distribution along the tape may affect force calculations. The second one is measurement inaccuracies in tape height impact charge estimation. Then about the two follow-up questions. First, what if? My answer is the point charge model in Lab 1 overestimated the charge because it assumed all charge was concentrated at one point, while in Lab 2, the line charge model distributed charge along the tape, leading to a more accurate and slightly lower charge estimate. The line charge model better represents the real electric field and force interactions. Then the second question, why? My answer is the estimates differ because the point charge model assumes all charge is concentrated at one point, oversimplifying the force calculation. The line charge model more accurately represents the real charge distribution, making it closer to the actual value. And thank you.